Could've sworn I was dreaming, for her I was fiending, so I had to take a little ride.
Hi. Assalamualaikum. My name is Putri Nubalkis binti Ahmad Razak, S70943.
My name is Ahmad Huzaifah Muhammad Sahibul, S70606.
My name is Muhammad Hairul Ikhwan bin Ahmad Syahid, S70351.
My name is Muhammad Faikali Amran, S70125.
My name is Muhammad Farhan bin Zuhari, S70113.
We are from Group 15. We would like to present about FET.
MESFET
MISFET.
and MOSFET.
So here we go. Okay, bye. Now I'm going to present to you guys about FET, that is Field Effect Transistor. What is Field Effect Transistor? Field Effect Transistor is a semiconductor device that consists of a channel made of a semiconductor material with two electrodes connected at either end, namely the drain and the source. The flow of current between the source and the terminals is controlled by a third electrode, known as the gate, which is placed in close proximity to the channel. By applying a voltage at the gate terminal, the number of charge carriers in the channel can be modulated, leading to a corresponding change in the current flow between the source and the drain terminals. How is field effect transistor working? Let me tell you guys. When a voltage is applied to the gate electrode, an electric field is created across the insulating layer, which in turn creates a depletion region in the channel. The depletion region reduces the number of free charge carriers in the channel, and thus the conductivity of the channel is reduced. This effect is known as the field effect, and it is the basis of the FET operation. In the case of an N-type FET, a negative voltage applied to the gate electrode creates a depletion region in the channel, which reduces the flow of electrons from the source to the drain. In contrast, a positive voltage applied to the gate electron of a P-type FET creates a depletion region that reduces the flow of holes from the source to the drain. To explain the working principle of FET, the analogy of water pipe and vessel can be used. In this analogy, the source of water can be considered as the source terminal of FET, while the vessel that collects water can be analogized to the drain terminal of FET. The gate terminal can be compared to the controlling tap that regulates the flow of water. Similar to how the tap modulates the flow of water, the voltage applied at the gate terminal controls the flow of current from the source to the drain terminal of FET. Thus, the FET operates by controlling the flow of current through the channel by modulating the number of charge carriers in the channel using the voltage applied at the gate terminal.
Okay, MISFET. In MISFET, metal insulator semiconductor field transistor, the controlling terminal gate is isolated from the device by placing an insulator between the gate and the channel, a positive and channel negative. The channel voltage is applied to the gate to form a channel in the substrate by induction. The channel discrete allows the controlling of the current when the insulator is oxide. It is known as metal oxide semiconductor field effect transistor MOSFET. Go to basic operation of MOSFET. When a positive voltage is applied to the gate relative to the substrate which is connected to the source, in this positive charge are in fact deposited on the gate case metal. In response, negative charge are induced in the underlying exit by the formation of a depletion region and a thin surface region containing mobile electrons. This induced electron from the channel of the FET and allow current to flow from drain to source. Okay, the metal insulator semiconductor FET, MISFET. One of the most widely used electronic device, particularly in is the metal insulator digital integrated circuit semiconductor MIS transistor. In this device, the channel current is controlled by a voltage applied to a gate electrode that is isolated from the channel by an insulator. Okay, that's all from me, MISFET. Okay, we go to next person.
Thank you, Zai. Now I will explain about MOSFET. So, what is metal oxide semiconductor field effect transistor? MOSFET is a type of field effect transistor that is widely used for switching purpose and or for the amplification of electronic signals in electronic device. It has an insulated gate, the voltage of which determines the conductivity of the device. MOSFETs can be made with either P-types or N-type semiconductors, and complementary pairs of MOS transistor can be used to make switching circuit with very low power consumption in the form of CMOS logic. The basic principle of the field effect transistor was first pretended by Julius Edgar Lilienfeld in 1925. MOSFET application. MOSFET can use as amplifiers, and then it also can use in automobile sound system and in sound enforcement system. MOSFET are used as escalator in radio system, and lastly, it also can be used in the application of power electronics and switch mode power supplies.
Now I would like to continue about disadvantages and advantages of MOSFET. For advantages, it high impedance. MOSFET are very high input impedance, which make them ideal for use in application where power consumed is concerned. Next, for high temperature tolerance. MOSFET can be operated at high temperature without any problems, which make them ideal for use in application where heat is concerned, such as power supplies and voltage regulator. Next, for low noise. MOSFET are very low noise device, which make them ideal for use in sensitive electronic circuits such as audio amplifier and medical device. Next, for disadvantages of MOSFET. Firstly, it is very sensitive to static electricity. MOSFET are very sensitive to static electricity, which can damage them. This means that they need to be needled very carefully, especially during assembly and installation. Next, for the cost. MOSFET can be more expensive than other type of transistor, which can make them less attractive for cost-sensitive application. Next, for threshold voltage sensitivity. MOSFET are very threshold voltage, which is the voltage required to turn them on. The voltage can be vary from device to device, which can make it very difficult to achieve consistent performance.
Then I will continue to my part, that is MESFET. For you want to know, MESFET is the acronym of the metal semiconductor effect transistor. It is similar to FET, but the difference is instead of PN junction in FET, metal semiconductor is using Schottky junction. The conduction is controlled by the gate terminal and the depletion. Alright, MESFET also will be known in the depletion mode. MESFET is normally on, and in the enhancement mode, MESFET is normally off. In the depletion mode, the size of the depletion layer increase, and thus in the symbolic gate terminal, in the depletion mode is thicker. The arrow points outside in the P channel and arrow point inside the N channel also will be different. I will define the structure of MESFET. The first is a self-aligned source and drain. Here, the length of the gate is equal to the length of the channel which run from source to drain. Gate is formed first, then the source and drain are formed later. Gate material should be able to withstand the heat formed during the ion implantation of source and drain. So, only some limited material are used for gate terminal. Source and drain terminal are taken from highly doped N-type semiconductor layers. The source and drain form of ohmic contact, and in the between that the two terminals Schottky contact is fabricated. The second is non-safe aligned source and drain. Here in this type, source and drain are formed first, then drain. The gate is formed, so gate is placed only a section of the channel and it does not cover the whole channel. In MESFET, we got 3 to apply MESFET. The first one is MESFET in a circuit. Second is MESFET as a switch, and the third is MESFET as an amplifier. In addition, the MESFET requires a bias circuit designed to provide the correct DC voltage to the source and gate terminals. Also, it is important to match the impedance of the input and output of the circuit to have the best performance. Alright, I will tell you about the MESFET in a circuit. MESFET in a circuit, the basic of MESFET consists of a source terminal, a drain terminal, and a gate terminal. The source and drain terminal are where the current flows, and the gate terminal control of the flow of current through the device. The voltage applied to the gate terminal controls the amount of current that can flow between the source and drain terminals. The second, MESFET as an amplifier. MESFET as an amplifier by applying a small voltage to the gate terminal and using the resulting change in current flow between the source and drain terminals to amplify the input signals. Last part, MESFET as a switch. MESFET as a switch, you can apply a voltage to the gate terminal that is above or below a certain threshold value. This will cause the MESFET to turn on or off, allowing or blocking current flow between the source and drain terminals. Conclusion for this topic: acid that of amplifier using electrometric tubes and capacitive choppers according using different kinds of field effect transducer in electrometrics device is wise.
So that's all from us. I hope you guys enjoy our video. Okay, bye!
Bye!